Hello, welcome to my channel Physics with Shabnam Khan. So far we only know the means to generate electricity is a battery. Now what if we want to generate electric current without using a battery? The current which is generated using a battery can be used only on a small scale, like our toys, your TV remotes and your mobile phones, etc. etc. Now what if we are required to supply electric current to millions of houses around the world? Then what we can do? Can we build a large battery? If we can build, then imagine what amount of chemicals will be required to make such a huge battery, which can be drastic, right? So why not we think about in generating electricity without using a battery? There was one person in the past whose name was Michael Faraday. He also was in the same thought process of generation of electricity without using a battery. Now let's think about let's think like in Michael Faraday and think about various means how we can generate electricity without the use of battery. Now if we know our previous knowledge, from the previous knowledge we know that this is nothing but electromagnet. What is electromagnet? Electromagnet is nothing but when we pass a current through a coiled wire, there will be generation of magnetic fields around it. That means using electric current we can generate magnetic fields. Now why not we think a reverse of this? So there was a person, Michael Faraday, who was thinking that if electric current can generate magnetic fields, so why not magnetic fields can generate electric current? Now let's think like Michael Faraday today. Now for that purpose, we have taken a coiled wire connected to a bulb and a magnet. We don't have a battery over here because we are trying to produce electric current without using a battery. Now we know that a magnet has a magnetic field around it in the direction from north to south. We know this. And let's also connect in this circuit, a small circuit which is carrying a coil and a bulb. We will connect a voltmeter to check whether any voltage is being developed or no, or when any current is going to flow or no. Now let's try to pick up this magnet and try to pass this magnet through a coil. Oh, there is a blink in the bulb, right? The bulb just blinked and stopped when I just stopped. When I'm moving this magnet through this, it just blinked and then it stopped. So let's stop it over here where it was blinking. I stopped at this place, but now the bulb is no more blinking. Now, there is no glowing in the bulb right now. So what does that mean? If I'm just moving the magnet continuously, there is a generation of light in the bulb. There is a production of light in the bulb. But we can also observe the deflection in the voltmeter. That means the voltage is being developed. Now if I just try to go away, the intensity of the bulb is decreasing. But when I try to go away inside the loop, inside the coil like this, the intensity of the bulb is increasing. That means wherein I have the more magnetic fields, the intensity is increasing. The light intensity is increasing. But when I go back, as the magnetic field lines, the density of the magnetic field lines is less, the intensity of the light of the bulb is also less. So this is what we can understand from here, that wherein we have number of magnetic field lines more, the intensity of the bulb is more, that means more current will be developed. But where we have less, as I go away from the loop, the intensity of the bulb also reduces. But when I am steady with the magnetic field or a magnet, there is no generation of electricity. The generation of electricity is only till the time I am moving the coil, I am moving the magnet. Yes? So what we are observing over here, that the intensity of the light increases as we go towards the coil, and as the magnet goes away from the coil, the intensity of the light decreases. That means the amount of current produced is more when we go towards the coil, but when the magnet goes away from the coil, the intensity keeps on decreasing. As you can see, the deflection, as the magnet is going towards that side, it's negative deflection. As the magnet is going towards this side, right hand side, it is positive deflection. So we can say that the intensity of the magnetic field lines, where it is more, which is passing from inside the loop, there we can see the current produced is more. But when the intensity keeps on decreasing of the density of the magnetic field lines keeps on decreasing, there we can see the current flowing is less. So we don't have to worry about the direction, that we are going to study in the next video. But here, as you can see, the intensity of the light keeps on increasing and decreasing as the magnetic field lines which is passing from inside the loop is less or more respectively. Now, when magnetic field lines is less, the current will be less, and the magnetic field lines passing is more, the current will be more. So we can say that when the magnet is steady, there is no production of electric current, but when it is moving, then only the production of electric current is there. That means the moving or the changing magnetic field is only able to produce electric current. There is no battery over here. So using the magnet and a coil, we are actually producing electric current. So we can say that changing magnetic field is able to produce electric current, and the current which is produced is called as induced current, because it is induced using a magnet and we are not using a battery, and the voltage developed is called as induced voltage. So this process of producing electric current using a magnet is called as electromagnetic induction. So because this is an induced current or induced voltage which is we are going to produce using the magnetic field lines. Now we can say that magnetic field lines not producing electric current. Instead, changing magnetic field lines produce electric current, and thus the current which is produced is called as induced current, or the voltage which is produced is called induced voltage. Now when Michael Faraday had had a success in producing electric current using magnetic field lines, people were saying that what's a big deal if you have produced electric current using magnetic field lines? It's not a big deal. So Michael Faraday replied to them that there will be one day the whole world will be powered up using this technique, using this process. So now, yes, it's correct. In our electric generators, we use this process only. That is, we are producing electric current using the magnets. Moving coil or moving magnets is the process inside the electric generators. So in our next video, we will see how electric generators work. Till then, bye-bye. Take care.